This is a video about balancing chemical equations with several examples and helpful hints. Before we get started, I just want to say that there are some people who can just look at an equation and balance it. If you don't need the hints, or you have your own way of doing it, that is just fine. This is just in case you get stuck or to make it a more efficient process. Okay, our first hint, save lone elements for the end. So if we look at this unbalanced equation, remember that the first step is to write our atom inventory. Let me get my pen going here. So we're going to go under the yield symbol. We're going to have aluminum, iron, and oxygen. Remember, each capital letter starts a new element symbol. So aluminum, there's nothing, no subscript, we assume one aluminum. The same with iron and oxygen, one of each. On the right side, one iron. We have subscripts for aluminum oxide, so we have 2 aluminums and 3 oxygen atoms there. So this isn't balanced. If it was balanced, we would have matching numbers of atoms on each side. So we're going to start, and the advice here is to save the lone elements for the end. Aluminum, we can put any number in. Iron, we can put any number in, so we're going to start with our oxygen because it's the only one that isn't lone. So we have 3 on one side, 1 on the other side. If we have 3 here, we need 3 here. So what number do we put in front? Some number times 1 to give us 3, which will be 3. 3 times 1 gives us 3 oxygens. Remember, the coefficient applies to the entire formula. So we also have to update iron. We have 3 irons. Now we can go back and do our lone elements. So we have 3 irons on the left. We need 3 irons on the right. 3 times 1 gives us 3. And for oxygens, 2 on the right. We need 2 on the left. And we should be all set. Let's double check. 2 times 1 is 2 aluminums. 2 aluminums. 3 times 1 is 3 irons. 3 irons. 3 times 1, 3 oxygens, and over here 3 oxygens. Usually we fill in the blanks with a 1. Okay, let's go on to the next one. Hint 2. If an element appears more than once on a single side, balance it last. Okay, so for this reaction, the combustion of propane, we're going to list carbon, hydrogen, and oxygen. And then we'll count them up. Carbon we have 3, hydrogen we have 8, and oxygen we have 2. That takes care of the reactant side. Now over on the product side, remember this 2 only applies to the oxygen. If there's no number, we assume 1. So 1 carbon. Oxygen is kind of crazy here though, because we have 2 right here, and then we have 1 more over here. So that's 2 plus 1 gives us 3 oxygen. And hydrogen we have 2. As you can see, oxygen's a bit more complex. There's more to keep track of. So let's save it for last, because oftentimes these problems will work themselves out by the end. So oxygen last. Let's start with carbon. 3 carbons on the left. We need 3 on the right. So what coefficient do we add? We add a 3, because 3 times 1 gives us 3. 3 applies to the entire formula, so we have to update oxygen. We have 3 times 2 is 6 oxygen, but remember, we've got 1 more over here, so that's 6 plus 1 is 7 oxygen. Next we go, carbon is good, so we go to hydrogen. We have 8 on the left, we need 8 on the right, so what coefficient do we put in here? We're going to put a 4, because 4 times 2 gives us 8. The 4 applies to the whole formula. We have to update all of our oxygens here. So we have 3 times 2, that's 6 oxygens. 4 times 1, that's 4 oxygens. 6 plus 4 gives us 10 oxygens. Well, check this out. We can just put a single number in here and make it work. We have 10 oxygens on the right. We need 10 on the left. So what will we put in here? We'll put a 5. 5 times 2 gives us 10 oxygens, and we're balanced. So by saving the oxygens for the end, we didn't have to unnecessarily confuse ourselves at the beginning. Let's double check. We'll put our 1 in. 3 carbons, 3 carbons. 8 hydrogens. 4 times 2 is 8 hydrogens. 10 oxygens. Well, we've got the 6 oxygens right here. 3 times 2 is 6. Plus 4 more. 4 times 1. 6 plus 4 gives us 10 oxygen. We're good to go. Next hint. If you get stuck, start trying out coefficients on the most complicated formula. Sometimes you get to work in a way and you just can't make it work out, or you can't figure out what to do. So in this case, we would say, this is a problem that people commonly have with this particular reaction. They get stuck. So let's assume we've gotten stuck. We don't know what to do. We've erased all of our work. We come back and we say, well, the most complex formulas are KNO2 and KNO3. We're going to go with KNO3. It's a lone formula on one side. The coefficients either going to be 1, 2, 3, 4. Generally, coefficients don't get that high most of the time. So if we just start trying out a 1, well, 1 didn't work. Then we'll try a 2. Would 2 work? If it didn't work, we'd try a 3. So the beginning of each of these problems, atom inventory. We have K, we have N, and we have O. On the left, no number tells us it's 1K, 1 N, and 3 O's. So 1K, 1 N, and 3 O's. On the right, we assume 1K, 1 N. Oxygen is going to be 2 plus 2 is 4 oxygens. So we know with the number 1 in front that this didn't work, because blanks just we assume a 1 there. So it's not balanced. Let's try a 2. If we have 2, now we have 2 times 1, 2 Ks. 2 times 1, 2 Ns. 2 times 3, 6 O's, 6 oxygens. So now we see, can we balance it with that 2 there? Well, we have 2 potassiums, 2 Ks. We need 2 on the right. So what do we put here? We put a 2. 2 times 1, that's 2 potassiums. 2 times 1, that's 2 nitrogens. And now adding up all of our oxygens, 2 times 2 is 4 oxygens, plus 2 more, 6. Look at that. We're balanced. We'll put our 1 in here. Double check. 2 potassium, 2 potassium. 2 nitrogen, 2 nitrogen. 6 oxygen. 2 times 2 is 4, plus 2 is 6 oxygen. So this one, it worked just by trial and error. Say a coefficient of 1 didn't work. Let's try a 2. If 2 didn't work, we'd erase everything, try a 3. Just a suggestion if you get stuck, or whenever you have a lone formula on one side. So instead of this plus something else, you can just start trying coefficients. Okay, next one. When we have polyatomic ions, sometimes the equations can get really complex and you're adding things up all over the place. So to simplify on an equation like this, what we do is we say, what polyatomic ions do I have here? NO3, NO3. It shows up on both sides. That's key. OH, OH. Remember, you can look at your table of common polyatomic ions if you don't already recognize them. So what are we going to do here? We're going to say let X equal NO3. That's this whole unit here. Let Y equal the OH. Then we're going to rewrite this substituting in. So wherever there's an NO3, we made it an X. Here's an NO3, we made it an X. OH, we're going to make it a Y. OH, we're going to make it a Y. This just makes it easier to balance. We're not keeping track of all these oxygens and multiplying to get big numbers, so this makes it more simple. So now we do our inventory. Aluminum, X, sodium, and Y. And let's add up. On the left we have 1 aluminum, 3 X's, 1 sodium, and 1 Y. On the right we have 1 aluminum, 3 Y's, 1 sodium, and 1 X. It's not balanced, but let's look and see what we can do. Well, if we have 3 x's on the left, we need 3 on the right, so let's draw a 3 in here. That updates the whole formula. So now we have 3 sodiums and 3 x's. Let's see, where else are we unbalanced? Aluminum's good, X is good, sodium. Okay, we have 3 sodium on the right, we need 3 on the left. So what do we write in? We write in a 3. 3 times 1 gives us 3, and also 3 y's. And look at that, we're balanced. We put a 1 in here and a 1 in here. We wouldn't leave it in this form because actually x and y were not the given equation up there. So let's transfer our coefficients up. 1, 3, 1, and 3. And let's double check it. 1 aluminum, 1 aluminum. Let's see, with nitrogen, 1 times 3 is 3 times 1, 3 nitrogens. Over here we have 1 times 3, 3 nitrogens. Oxygen, let's actually save oxygen for last because it's kind of all over the place. Hydrogen, we have 1 times 3 is 3 hydrogens, and we have 1 times 3, 3 hydrogens. Times 1 actually, still 3 hydrogens. Now oxygens, let's get all these together. So 3 times 3 is 9, times 1, still 9. Plus 1 times 3 is 3, so 9 plus 3 is 12 oxygens on the left. On the right, we have 1 times 3 is 3 times 1, so we've got 3 oxygens right here. And we have 3 times 3, 9 oxygens. 9 plus 3 is 12, so we have 12 on the left, 12 on the right. We're good. Using the x's and y's just simplified our process, but you certainly don't have to. You can count out all the atoms. That was 4 different hints, 4 different reactions. Hopefully that's enough to get you started balancing chemical equations on your own.